Good morning. So, I worked through all the problems in section 2 of the Clep review. Let's start with number 32. Now, I want to remind you this is supposed to be without a calculator. So, on number 32, first of all, we want to multiply these two together. Whether you use the box or you realize this is the difference of squares, you get x squared minus 5. If I throw it in the box over here, x minus the square root of 5 times x plus the square root of 5, we get x squared. Our diagonals are going to cancel, negative x square root 5 and positive x square root 5. And then negative square root 5 times positive square root 5 is negative 5. And this equals 5. So if we go ahead and solve this, we're going to add 5 to the right. And of course, we get x squared equals 10. And anytime you square root a variable, of course, you're going to get x equals plus and minus the square root of 10. All right, let's move on to number 33. I think we talked about some of these the other day, but I just wanted to include all of them. On number 33, we have f of x equals 2x plus 1, and g of x equals 3x minus 1. And they want you to do f of g of x. So what they're asking you to do is to take the g of x equation and plug it into f of x. So we have 2 times the g of x equation, 3x minus 1, plus 1, right where the x is, goes our equation. Now we distribute. 2 times 3x is 6x. 2 times negative 1 is negative 2, plus 1. And our final answer is 6x minus 1. Number 34. On number 34, it tells you that f of x is equal to the square root of x plus 2. So I want to start by talking about what that graph looks like. So if I were to graph that, first of all, remember the square root usually starts here and comes around. But this has moved 2 to the left. So we actually have this as our picture. And then we have a g of x is equal to x squared minus a, which means this is a parabola that's been shifted down, right? If it only shifts down 1 unit, it's going to cross this twice. If it shifts down 2 units, it's going to cross this twice. So what we're looking for is how long before when you take this and set it equal to 0, right, where it's going to cross here. So, for example, if I have x squared minus a equals 0, I take x squared equals a, and I square root both sides. However many I move it down, the square root of that, it can't cross it. So it has to be bigger than plus and minus 2, right? So in order for my parabola to only cross this one time, it has to be bigger than plus and minus 2, which means a can only be greater than 4. I think that's a better way to explain it after the other day. So let's move to number 35. On number 35. We talked about this one a little bit in class. It gives you n of t equals 1,000 times 3 to the 2t over 3. And it tells you that the bacteria grew from 2 p.m. to 8 p.m., which is 6 hours. All right, so if we go ahead and plug 6 in for our t, we get 12 divided by 3, or our exponent is 4. Well, 3 to the 4th power is what we have to do next by order of operations, is 81. And so we end up with 81,000 when we multiply these. However, the question says how many more bacteria. This 1,000 is our starting amount. So how many more means we got to subtract that 1,000, and we actually have 80,000 more. All right, number 36. On number 36, it says the equation of the line shown in the graph above is y equals ax plus b. So this graph, if you're looking at it, it has a line that kind of crosses this direction. So here's some things it's telling us. First of all, this is our y-intercept, which means our b value is less than 0. It's got to be negative. Our slope, or our m, is going up. So this has to be positive. All right, and they're asking you to use y equals ax plus b. So really your slope is the a value in this equation. So in this equation it says that b has to be negative and a has to be positive. Therefore, out of your options, if I take a positive times a negative, it's going to be negative. So a times b is obviously going to be less than 0. A positive times a negative is going to be a negative. Number 37. On number 37, we have y equals 1/8 x to the 3 halves minus 8. And it wants us to find the x-intercept. For the x-intercept, you put 0 in for y. So I have 0 equals 1/8 x to the 3 halves minus 8. Adding 8 over. All right. And we talked about how you can clear the fraction here. So we get 64 equals x to the 3 halves. All right. Now to get rid of the 3 halves, we've done it a couple different ways. Right? This is power over root. So really we can take and do the opposite of that and say we're going to do 2 over 3 to both sides. So really we're taking 64 to the second power inside a cube root. Or you can start by doing the square root first. How do you get rid of a square root? You square it. And then you're going to take the cube root to get rid of cubes. Either way, we have this 64 inside, a cube root, and it's squared. So the cube root of 64 is 4. And then the square of 4 is 16. All right, number 38. On number 38, we have h of x equals the log. Here, let me just clean that up a little. The log base 2 of x squared plus 2. And it says that h of x equals 3. So we're going to plug 3 in here. So we have 3 equals the log base 2 of x squared plus 2. So to get rid of log and to solve for x, we have to do it or change it into exponential. To change it, we take the base of the log as the base to our exponent. Our exponent is the 3 on this side equals what's behind the log, which is x squared plus 2. 2 to the third power is 8. Equals, sorry about that, guys, equals x squared plus 2. Subtract 2 to the other side, we get 6 equals x squared. And of course, square rooting both sides, technically we get x equals plus and minus the square root of 6. However, the question wants you to take only the positive value. So therefore, x equals positive square root 6. All right, for number 39, let's try that one. On number 39, it gives you 3 different ways that y and x are related. You need to decide which ones define y as the function of x. So first of all, the first one is x squared plus y minus 3 squared equals 4. If you look at this one, that's supposed to be a plus, sorry, this is a circle, right? And in this circle, this, if I had a circle, would not be a function, correct? If I were to draw a vertical line down or do my vertical test or pencil test, it would cross it twice. So this is not a function. So I is not an option. The second one is a table. And you'll notice when you look at the table that none of them repeat. So I is good, or the second one is good. Number 2. In number 3, they give you a picture. You get this one up here. Let me put number 2 is okay, no repeats, right? So it is a function. In number 3, it gives you kind of a picture like this, and it comes up here, and goes up, and then comes down here, and finishes. Well, you can also do the same thing with this one. Vertical test, vertical line test, or the pencil test. If you cross through this, it only crosses each one just one time. Since these dots are open, this fills in the spot. So again, it's only one time. So that means in this case, both 2 and 3 are functions and work. Talk about number 40. On number 40, we have 2x plus 2y equals 1. And we have 4x minus y equals 4. And it says that it intersects at the point with coordinates a, b. What is the value of b? So we are actually looking for the y value of where they intersect. All right, so we can do this a couple different ways. We can get rid of x, so we have y right off the bat. So if we multiply the top one by a negative 2, we have negative 4x, negative 4y equals negative 2. We have positive 4x minus y equals 4. Adding these together, our x's drop out. We get negative 5y equals 2, dividing both sides by a negative 5, and y equals negative 2 over 5, or negative 0.4. Either answer would be acceptable. Continuing on to number 41. In number 41, they give you a graph. And there's some things on the graph that are super important to pay attention to. So first of all, if it crosses through this point, right, and actually the graph kind of does this, it does a wave over and over, which means if it is crossing through here, this is a sine function, sine of x, right? If it's starting down, that means that we have a negative sine x. And you'll also notice that at the bottom, right here, that negative 3, that's your amplitude. So this is our basic function to begin with. Now what we need to decide is what our period is. So remember that the period is what falls behind the sine along with the phase shift. In this case, the period, remember, is 2 pi divided by b. And b is what is sitting in front of the x value. If you look at the picture, one full wave finishes at pi. So we know that this has to equal pi. So if I multiply b over, I get 2 pi equals pi times b. And of course, we can cancel the pi's. So we know b has to be 2. So up here in my equation, I know this is going to be a 2x. Now, as a phase shift, if I wanted to shift this one whole pi, it'd still be going down, right? So the idea is we need to figure out how we can move it so it actually moves only to here, which is pi over 2. So that it's going to start up with a positive shift. Instead of it being negative here, we want it to be a positive 3. So that means that if I have 2x minus h, I need that to equal a positive pi over 2. So first I'm going to clear the fraction. That gives me 4x minus 2h. Alright, let me try and write that again. Sorry about that. Clearing the fraction, I get 4x minus 2h equals pi. Trying to solve for h. I'm going to subtract 4x to the other side. So I have negative 2h equals negative 4x plus pi. And then if I divide everything by a negative 2, I get h equals 2x minus pi over 2, which is not an option. Alright, so let's look at this. I know in here that I need to be shifting it over. I know it's got to go to here. So let's check my math. So I have 4x minus 2h equals pi. Divide by 2. Alright. We know we're shifting it over. And we're shifting it. That's where I went wrong. Notice in order to go from here to here, I need to shift it to the left. Which means, tell me about this. It should have been positive, right? Alright, so if this was a positive h, this is going to change our problem. We end up wanting it to shift. We know it's going to be an amplitude of 3, sine of 2x minus pi. If you graph this and you graph the original one you got, they should come out to be exactly the same, only moved over. Okay? Alright, let's talk about number 42. Alright, on number 42, we have f of x equals x plus the absolute value of x minus 10. And it wants to know for which of the following defines f of x for all x less than or equal to 10. So the easiest way I would suggest is it says less than or equal to 10. I would start by plugging in 10. So you get 10 plus the absolute value of 10 minus 10, and it equals 10, right? 10 minus 10 is 0. All right, let's try something smaller. What if I have 9 plus the absolute value? Gosh. Absolute value of 9 minus 10. This is negative 1, but because it's absolute value, it's a positive 1. So this also equals 10. Let's do one more. 8 plus the absolute value of 8 minus 10. 8 minus 10 is a negative 2, but the absolute value makes it positive 2. 8 plus 2 also equals 10. So, no matter what you're plugging in here, your value is going to be 10. Number 43. On number 43, it tells you that the table are values of the function f. If f is linear, so the fact they're telling you it's linear tells you that you have a constant slope. So in the table, they give you x and f of x, and this is 5a, 1032, and 15 in B. And they want to know what A plus B is. Okay? But they're telling you it's linear. So what I chose to do is to find the slope between the first two and set it equal to finding the slope between the second two. So if I take 32 minus A over 10 minus 5, that has to equal, because the slope is constant, B minus 32 over 15 minus 10. Now, we have 5 on the bottom for both of them. So really the 5's cancel, and we only have to pay attention to the top. Right? So first thing I want to do is I am going to add 32 to this side so I can get B by itself. So I get 64 minus A equals B. Then I'm going to add A to the right. So I have 64 equals A plus B. And that's what I'm looking for. Okay? So if they tell you it's linear, they're telling you that so that you can use the slope. On number 44. They give you a graph that looks like this. Alright, lots of stuff you can see from this graph. First of all, it turns 2 times, which means this is an x to the third power. It also, the slope, or it starts up, the end behavior is up, down. Or if you think about this, it goes in this direction, so this is a negative function. And then you can also see that it crosses through at 0 for sure, so you know one of your zeros, one of these zeros is at 0. One of, not all, but one of. Okay? So we need a function that is an x to the third. It's negative because it's got to start up and finish down. And that if you factored out one of the variables, one of the x's, so you have a 0. So looking at those options, the only one that works is g of x equals, here's our negative to the third power, x to the third, plus 4x. Because I could undistribute an x, that would give me my 0 at 0. It is negative, which gives us this behavior. And it is a cubic because it turns twice. Okay, let's move on to 45. On number 45, they give you that the natural log of A is equal to 2.1, that the natural log of B is equal to 1.4, and they want you to find the value of the natural log of A squared over B. Alright, so first of all, let's expand this. This is the natural log of A squared minus, in the log world, when you divide, you really subtract, the natural log of B. Then this 2 has to go out in front, right? So we have 2 natural log A minus natural log B. And then it tells us the natural log of A is 2.1. So we have 2 times 2.1 minus the natural log of B, which is 1.4. So 2 times 2.1 is 4.2 minus 1.4. And if you go ahead and do that subtraction, you get 2.8. Alright, so we're going to pause this video for a few minutes. I have a class coming in. I will finish 46 through the end in my next break.